Objective here is to try to increase the temperature at which this Keurig 2.0 coffee machine puts out. The interesting part about this is opening it was a pain in the behind. It has one screw on the side, so the screws below. It wasn't very obvious that this actually pounds down and comes out, slides out, and after that comes out, then this just pulls apart, and that's the inside there. I'm going to report the rest of the housing, see if I could find the temperature sensor. I don't know, might be a thermistor, might be a type K thermocouple. So the plan is try to figure out what they have and then try to basically put a shim between it or somehow increase the thermal resistance so that the machine senses the temperature that it does when it cuts off at a little bit higher, so the heating element will run a little bit longer. Finally got this thing open. This has the rank as one of the most difficult, if not the most difficult appliance I've ever opened. That clip there, that one came out easy because this side has a lot more flex in it. This side doesn't have much flex because of the bottom here, all kinds of little issues. This clip here, extremely difficult to get out. The thing goes in and clips inside there like that. So when you pull outwards, you're pulling against this. This was particularly challenging to get out. Anyway, after much effort, it's out. So let's have a look at the main body here. As you see, this is the pump. This is a motor, right? Ordinary DC motor. You could tell possibly something like a 775. Looks reasonably powerful. Coming down here, I don't know if it's a gearhead. Chances are it has a gearhead in here because you want to reduce your revolutions. This is basically a crankshaft, something like what you would get in an engine, and a piston here, as you can see inside there, and that piston, properly like an engine, that piston is what's using to pump the water. So that's your pump there. That's your main pump. That said, on the other side, there's something noted that says, let me see if I can get the focus. Right, there's something that says mini pump. I have to go and check up the numbers of this, but I'm pretty sure this is an air pump. Simple giveaway here is that there's only one, line. So, that sort of kind of gives it away. I mean, water pump is supposed to have an in and an out. So I suspect it's an air pump. Again, simple DC motor, no caps on it. And they're going through, coming here, and pushing that air up through inside here. Not sure what that does, if it bubbles through something. I haven't looked at the mechanism on top. Then there's another feed that's coming, and that's going around and coming. Let me see if I can flip this around. Right, that's coming to the board. So there's a sensor here, somewhere in there, that's basically picking up that the air pump is on through pressure at that point. It could be a pressure sensor, parametric type thing. Maybe something from these people, we call them Bosch. They tend to do good stuff like that. And then there's a third one that is coming to the top of this chamber. This is the heating chamber. So this chamber has, well, I've already removed this. This is the whole objective, is to try to make sure I can get this thing to actually run at a higher temperature. I need to pull off a number of this. That's going to be difficult by itself. Writing's a bit small and it's shiny, so not sure how I'm doing that. But basically, I think this is essentially the switch on and off the thermistor. It may be a thermocouple actually. I'll have to check that up. So when I check that, I'll confirm what that is. That goes here and it bolts down here with this piece. So that's onto this. This is a split stainless steel and then plastic on top, and the water, air pressure coming in, water coming in, and this, it appears to be emergency cutoff for the heating element. If you look very carefully, let me see if I can get a screwdriver to point this out. If you look very carefully down at the bottom of this, right, there's the water coming in. There's one thing here, another there. Those are the two contacts for the heating elements. there's a contact on the top here that appears to check water level inside of this. So we have those two contacts, and we have one contact is coming through this. So I suspect this is an emergency cutoff, and essentially if it gets too hot, this cuts off. This is also a secondary cutoff. I have to see if I can read the number of it. It's strapped, stainless steel strap on. Trying to take this out and put it back in will be a pain. I'm trying to get this to work, so I'm not going to interfere with that. This here, oh, just jumping back onto that. This is a sensor. This is an optical sensor. So basically, when it revolves, it goes through this goes through here, and basically it counts every revolution. So it knows how much revolutions. It's a piston pump, so it will have a fixed amount of flow per second. So it's fairly easy to tell what's going on. Apart from that, so I'm going to try to shim here, put something in here, put this back together and see if it works. Okay, apart from that, let's jump onto the board itself. As far as I understand it, and I'll explain it a little bit further. Power comes through, power comes, one side comes from this, passes through this, and then goes to the red. And then this is the other side. So let's go onto the board itself. The back of the board is easy to see compared to the front, where it's a little bit difficult to get. I'm trying not to again disassemble too much so that I don't have to reassemble and not spoil anything that cause any problems. The whole board is conformally coated, properly labeled. Secondary side, we have enough silk screen markings, really a properly well done board, and correct thing for a device like this, so you have to give them credit. The pump that we just looked at, again, suction coming from here, which is the input to the from the reservoir. So that coming and into there, and then going out, and that goes to the bottom of the same heating chamber we looked at. This side goes to our water level meter, and basically this gives the board feedback on what water level is in the reservoir. Further than that, when things over, you have an overflow from this, I guess in case there's back pressure for any reason or anything else, and that goes here and comes to the top. That top piece is the little piece that's onto that frame that goes over and flows back into the same water bottle. So that is what we have on this side. As we discussed again already, this pressure sensor, air pressure sensor. Looking at the electrical connections now a little bit further, let's flip this a little bit again and have a look at what it did for power. Right, so this is the power side of the board. Again, as I said, the board is difficult to come out, so I'm not going to try that. I'm just going to get down to doing this thing manually and trying to ratchet thing and then get ahead with it. Looking quickly at the power side of things now. As we said, this is your incoming cable. The incoming means supply, one end crimped, and that goes to the black. That black goes across onto the black that we just looked at with the thermostat, I suspect, and comes back to the red. That red then I suspect connects to this. I'll have to test that, and that goes off to the black on the bottom of the heating chamber. The other side is the white, which is just crimped straight on to this next lead, and that's it there. If you look a little bit, just glancing in from here, we can see a mauve, which is pretty good. I suspect that's a class rated capacitor. We could see the yellow tape and a small transformer, suggesting that there's a switch mode power supply in here. Makes sense because you'll need something for the control board. We do not know what microcontroller is used without actually opening this and stripping it down. And as I said, probably not worth it considering what I'm trying to do. Everything is properly well grounded. There's a set of ground things, nice and green, grounded here. I would give them again, good credit for doing proper electrical. The one interestingly kind of semi-interesting thing I've never seen before, funny-ish I would say, they've done, this here is the header for the display. They've done the display from the microchip here, and they've run this whole thing, all these lines. These lines all come from that connector there, come across here, come up on top, and get to the display here. It's an interesting approach. One would have thought what they would have done is something like a SPI bus and have a display with essentially micro in it, and it just needed a few lines to go, not all the pins. I guess this is cheaper to do all these wires than to use a display that's a little more expensive communication, and then just, you know, well, work it through that. So yeah, that's the longest lines I've ever seen on a display in any device. Interesting nonetheless. Let's see if we get people a little bit in the top here and see what they have. A few jumpers, nothing too fancy. A big resistor in there. Again, nothing too fancy. The whole header for the display here, and door switch, hot water, NDC. I should check and see what that works out to be. You have a 12 volts on jumper 8, and I cannot read the next one. So yeah, interesting little board, interesting little approach to things. Another view at the top here with what I suspect is a water level measure. Not a bad thing, not a bad little design at all. Just a pain in the ass to open. So let me see if I'm successful in putting some sort of thermal resistance between that, whatever might be a thermostat. I'll have to figure that out and see if it works, if it gets hotter. Well, it turns out my first guess on this was wrong. This is actually an interesting fusible link, 120 degrees I think I'm seeing on it, and essentially it's a lead coming in with a spring and 2 discs with a spring between them, and then a fusible substance, and once that heats to the desired temperature it melts and these 2 leads separate and essentially permanently destroys any connectivity. So this is your failsafe.